Hello students, today we're going to talk about angle measures and segment length. Please take notes as you go. So we have quite a few theorems that we're going to be going over today. So we'll do those and then we'll show you some examples on how they go. So the first one says, if we have ourselves a tangent and a chord that intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So let's take a look at what that's saying. So we have ourselves a tangent right out here, and we have ourselves a chord, which is here, and they're intersecting on the circle just like that. This is very similar to an inscribed angle. The measure of this angle 1 is going to be 1/2 of that arc there, and the measure of angle 2, similarly, is going to be 1/2 the measure of that arc BCA right here. Okay, so it's like the inscribed angle where it's 1/2 of the intercepted arc that is formed. The only difference there is that we don't have a second chord sticking out here. It is actually what is formed when we connect to the tangent sitting right there. So here's our first example. We want to find the measure of arc RST. So this is RST right here. I know that that is the arc, the intercepted arc of this angle that we find right there. So what we know is that the measure of RST has to be double that. So the arc is always going to be bigger than the angle. So I'm going to take 2 times 102, and I get a total of 204. Moving on to our next example here, we have line BC is tangent to the circle. We know that we want to find the measure of angle BCD, or CBD, sorry. So what we want to do, same deal, we want to set this up. So here's the angle that we know. We can either double this guy or we can cut this arc in half. I'm going to double the 5x because that's going to make a whole lot of whole numbers opposed to a half number when I divide 9x by 2. So if I do 2 times 5x, I get 10x. I subtract 9x from both sides, and I get x is equal to 20. In this actual problem here, I wanted to know what the measure of angle CBD is, or this angle right here, so I'm going to take that x and I'm going to substitute it back in. So angle CBD is found by doing 5 times 20 for a total of 100. Moving on to our next theorem, this says if two chords are intersecting in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So what is that saying? We have ourselves angle 1, and its vertical angle is over here. To find the measure of this angle 1, what we would do is looking at the two arcs, the two intercepted arcs that are formed there by itself and its vertical angle. And what we do is find 1/2 the sum, or essentially the average of those two arcs that I've highlighted there. So not only does this work for angle 1, but we can do it for angle 2. So for angle 2, let's do a different color. Angle 2, this would be its intercepted arc, and then the vertical angle, this would be its intercepted arc. So we have one that looks just like that for those two arcs there. So I could find the measure of angle 1 and then use that to find 2, and so on. Moving on, let's go ahead and use that as an example. I'm looking for this angle x here, and I see the two arcs that are associated with that. So that's the intercepted arc, and then its vertical angles there. So what I'm going to do is I'm going to add those two up and divide them by 2. So let's substitute those values in. So I have 106 plus 174 divided by 2. Adding those together, I get 280, and then dividing it by 2, I get 140. So the measure of that angle x there is 140. Now I could have gone through and found this angle as well if I really wanted to. Technically, in this case, it would be 40 degrees because those two things have to be supplementary. Our last theorem here actually is dealing with 3 different ones. So we have a tangent, a secant, 2 tangents, or 2 secants are intersecting in the exterior of a circle. What we do is to find the angle that is formed, it is related by being 1/2 the difference of the measures of the intercepted arc. So the difference means subtraction. So let's look at each example. So here's where we have a tangent and a secant. We're looking to find the measure of that angle 1 there. We find it by doing the farther arc minus the closer arc. So we're looking for the difference because the farther arc is always going to be bigger than the closer one. So the farther minus the closer divided by 2 equals angle 1. If we did 2 tangents that look like this, we have ourselves something that looks like this. We will do the exact same process. Now what I want to point out here is that if you look at arc PQR and arc PR, together they form the whole circle, and that's really important for you to know as you move forward and solve problems. So the last one here is when we have two secants. Again, it's always the farther arc minus the closer arc in here, and the farther one's always going to be bigger. Just keep in mind if you did the other way around, then you end up with some negatives. So let's go ahead and do some examples with that. Here's our first one. We want to find the value of x, so we're going to do the farthest one minus the closest one, and divide it by 2 is equal to the angle. So in here, I'm actually looking for the arc measure. Its process is still the same. However, what I'm going to do is when I create my farthest minus the closer, that's where our x value is going to be. So the farther arc minus the closer arc divided by 2 is equal to the angle. So as you can see, I still set it up all the same way. It's just the unknown now is in the parentheses. So I'm going to go ahead and multiply both sides by 2. When I multiply the left-hand side by 2, I get 144. When I multiply this side by 2, these 2 and that 1/2 will cancel. So I'm just left with what's in the parentheses. Moving the 200 over to the left, I get negative 56 equals negative x, or I can move the 144 to the right and x to the left, and that gets x is equal to 56. For this next example here, we want to find the value of x, which is this angle right out here, but the first thing we're going to need is this arc that's sitting outside. Now remember what I told you with tangents is we can do 360 minus whatever arc we have, because together they're going to form 360. So that's the first thing I'm going to do. I'm going to find the measure of arc ABC, so I'm going to do 360 minus 92 to get a total of 268. So I know that this piece here is 268 degrees, so now I'm going to use that to find x. It's always the farthest arc minus the closer one divided by 2, so 268 minus 92 divided by 2. And that's going to give me my measurement for x. So I end up getting 88 in this problem here. Okay, so here's some more examples. I know these are on the try this on the pink packet that you're working through. If you want to pause and give them a try and then come back to this, that would be a really good idea. So the first thing here we want to do is find the measure of angle 1. We cut that in half and we get 75. Second one here, we're going to find the value of x. This is the one where we have 2 chords. Add up the 2 arcs and divide it by 2, and you end up with the value of x equals 80. Okay, so now for this one here, it's a little bit tougher. We have 2 tangents with the sideline on the outside whose angle is 17.5. Our goal here is to find this arc right here. I know that it says in here equator, but don't look into that too much. What we want to do is find that. Now this is an unknown, that arc there, so I'm going to call that, so I'm actually going to call that one x, which means this other arc here, I'm going to represent that by doing 360 minus x. So what I have now is 17.5 equals 1/2. The farther arc is 360 minus x, and then subtract the closer arc, so subtract off another x. And that's going to be what I use to set up. So I'm going to multiply both sides by 2, and I get 35 equals, and I'm going to combine my like terms, so I have 360 minus the 2x. Then I'm going to subtract the 360 from both sides, so I'm going to do 350 minus the 360, and I get negative 325, and that's going to equal a negative 2x, so I'm going to divide both sides by negative 2, and I get 162.5, and that is equal to our x value here, which is the arc that we were looking for. All right, moving on now, we're going to look at segment lengths, which is a little bit different. So our first one here is discussing the chords that we have. So we have 2 chords. Now we discussed how to find these angles, but that's not what we're interested in now. Now we're talking about the lengths of these chords here. So what we do here to find the length, it's found by taking the 2 pieces of that specific chord and multiplying them together. It should be equal to if I multiplied the other 2 pieces together. So here's in relation to what we have on the right. These are time signs. For those of you who are not sure why that's a decimal, it's a time sign. So I'm going to do EA times EB equals EC times ED. Now I'm going to be using a lot of EBs, A's, and C's for these future ones, but they are different depending on the problem. So this one here is we're multiplying the 2 parts and setting it equal to the 2 parts over there. So here's our first example with this. What we want to do is same idea. We're going to multiply the 2 parts together for each individual segment, and what we end up with here is 3 times 6, and that's going to equal 9 times 6, or 9 times x. 3 times 6 is 18. And then divide both sides by 9 to get 2. So the value of this guy, in order to keep this, make sure that these are actually intersecting there, x will be equal to 2. Moving on to our next one here, this is when we have 2 secants, so 2 secants outside. Now the letters we're using look very similar to the last one that we just wrote down, but it is different. What this is saying is EA times EB. So we're doing this part to the whole thing, and then this part to the whole thing. So it's a little bit different. It's not EA to BA, it's EA and then EB. So part to whole and part to whole. And then the last one we have here is very similar to that last one. The only difference here is we have a tangent. So we don't have an extra piece for our tangent. So to make up for that, we're going to do something very similar. EC and ED for the other secant is still going to happen, so part to whole. But since part to whole is the same thing for the tangent, we're actually going to take that tangent and square it together. So let's look at a couple more examples. So we want to find the value of x here. So we're going to do part to whole and part to whole. Now the whole for the bottom one here is 10 plus x, and the whole for this one is going to be 20. So let's set this up. I know that LM times LN equals LO times LP. Substituting in my values, I have 9 times 20 equals 10 times the 10 plus x. Distributing through with the 10 and multiplying 9 times 20, I get 180 equals 100 plus 10x. moving the 100 and dividing by 10, I know x is equal to 8. So for this one here, now we have a tangent. Remember, the part and the whole are going to be the exact thing here. So we know we're going to be doing CV squared and then part to whole. The whole in this part is going to be 12 plus x. So let's substitute that in. We have 24 squared equals 12 times 12 plus x. Squaring out the 24 and distributing the 12. I'm then going to subtract 144 and then divide by 12. So the x value here is 36. We're going to try these. Go ahead and try these on your own. Hit pause and then come back to see if it's correct. Okay, so this is the one where we have two chords. So we have that relationship where it's the two parts of the chords that are going to multiply each other. So we have 9 times 12 equals 18 times x. Multiplying out the 9 times 12 and dividing by 18, you should have gotten x is equal to 6. On to this one, we have two secants. So once again, it's part to whole. So we're going to multiply by 11 times 21. And then part to whole, this is going to be the 12 plus x. So once again, when we set that up, and this is our result, multiplying, subtracting, dividing. X in this case was a decimal, which is 7.25. And then finally, for our last one, again, we have ourselves a tangent, so part and whole is going to be the exact same thing, so it's going to be 10 squared, and then we have part and to whole. The whole here is 5 plus 3x. And so when we set that up, distribute, subtract, and divide, we get x is equal to 5. All right, let me know if you have any questions, and I'll see you tomorrow.